Hello everyone, my name is Shimony. In the last few years I've been developing Bitcoin wallets, both enterprise and self-custody. Lately I've been taking the BOSS program of chain code, and I'm doing my first steps as a Bitcoin developer contributor. And today I'm going to talk about Miniscript. Why do we need Miniscript? How can we use it? And I hope you enjoy. This lecture is for the intermediate level, so I think even people that familiar with Miniscript will benefit from it. So first of all, let's talk about Bitcoin script. As you probably most of you know, there's no really need in addresses. We're just working with scripts, and address is just an easy way to share the format of the output script. Of course, we need an input script to unlock our script, and we need to satisfy those rules. Now, the script approach is instead of predefined command. When we have the script approach, we get flexibility and security and programmability. We can create any script that we want, but it's not that easy to create. As we will see, it's not that easy to create your own scripts. Now, the script language is a stack-based language, which is not so easy to work. And it's not Turing complete, which is the good thing that protect attack vectors on your node. And even that it's been for a while that we are using the script language, it has a limited template. Okay, for example, you don't have a template for Vault. Okay, for Vault implementation, there are different implementations. So we don't have templates for anything. You can create your own. But the problem is that you can create the same logic in many ways. And for example, you can create security risk, like maybe some path in your script will be you will not be able to satisfy them. Okay, and of course the cost, maybe you can create a different implementation that are not so efficient in terms of fees. And one more thing that it's very hard to achieve, you cannot compose in Bitcoin script. It's very hard because if you want to, for example, if you want to create multisig, that one of the policies inside of it, it's also a multisig. It's very hard to achieve with the script alone. So, just a reminder how scripts work. We take the input script, we concatenate it with the output script. Again, it's not that simple, but for our talk it will be enough. And in this example, we can see pay to pub key hash. We take the input script, we concatenate it with the output script, the script machine will run it, and if you get if it passes, then your transaction will be accepted by the network. Few script examples, like pay to witness pub key hash, make it even more simple to understand because the script is much more simple, but the script engine will add some operations. Okay, it's like it will add a few it will add the operation to put it on the stack. And the scripts are really very simple. It recognizes it by the type, and then apply the additional operation that it needs. Now, when we get to much more complex script, for example, like this one, that we have a 3 of 3 script that turns into 2 out of 3 after 90 days, it's not so easy. Okay, so this is still a script that you can understand, maybe write it by your own, but you can make mistake. It's not so easy, but the thing is that people wrote it before you, so So that may really helps, but again, what if we need a really complex script? Let's say we have a family that wants its own self-custody, and they have a challenge because they want the parents to be able to spend immediately, okay? Two parents, or maybe one parent with a backup key. But after 1 year, they want the kids to be able to spend it. If the 3 kids are getting along, they want it to be able to spend it together, or 2 kids with the lawyer office. But with the lawyer office, we don't want any problems, so we want the lawyer office also to be a multi-sig. Okay, so we have one condition, and after 1 year, it's another conditions, and more conditions, sorry, and even that it's you can sign it in different ways. So to write this by your own in BitcoinScript, it's very hard, really hard. For this, we have Miniscript. Okay, Miniscript is actually come to help us to create a complex script. It's a type language, okay, and it's written by, it's developed by Peter Walla, Andrew Polstra, and Sanket Kanjalkar. They all worked in the Blockstream. And it closed the gap between the high-level policies that we want to write and the low-level Bitcoin script. And it also gives us the ability to do analysis, composition, and optimization. And as Peter said that in his first lecture, it's really a combinator language of designing conditions. Now, Miniscript is based on 3-layer architecture. We have the policy language on the top level, which is human readable. I'm not sure about human readable, engineering readable. It's more likely. And then it will compile to Miniscript. Syntax will be a bit more complex. And in the end, it will be mapped into Bitcoin script, into low-level Bitcoin script. Now, the first thing, the upper level, is policy language. The policy language is a higher level. It's almost like to write in English. And you just express the spending condition almost like, as I said, engineering readable. And it serves as an input to the Miniscript compiler. Now, the compiler is with a dot because it's not really compiling, just, let's say we can call it a compiler, but it's not something like a language compiler. Now, we have different script fragments that can express the same policy. Would that mean that the policy to Miniscript is an implementation dependent? Okay, if both two implementations can create a different Miniscript expression. And also, policy language gives us something that's called probability, and we will see that later on. Now, the supported policies, the simplest one is just require a key to sign. It's PK with the name of the key, or with the key itself. And we have a time lock manipulation. We have the absolute time lock and the relative time lock. And then we have condition of end to policies, or we can create a threshold situation, like we want a few policies to be satisfied. And of course, manipulation, all kind of sham manipulation. Let's see some examples. The basic one is key requirement. We need the signature of this key. Second one, multisig 2 out of 3. Threshold, we just write the number of the signatures that we need from the list of the policies. We can see a vault here. We can see HTLC for Lightning. By the way, Lightning has a nice story that after they worked for a while on Miniscript, Miniscript created a better HTLC than the spec itself. Okay, so it's really efficient. Now, the thing we talked before about compose policies, we can see that we can create a multisig that is one of its available signatures will be also multisig inside of it. And also, here is an example for decaying multisig that you start with 4 needed signatures, and by the time you can reach to only 1 needed signature, you can see that those after let's say after 1 year, after 2 years, etc., they will be satisfied as one of the conditions that we need to satisfy the full expression. Okay, now the Miniscript as fragments. It's a type language. We're not going to talk about the type because it's very internal. If you really work inside optimizations of Miniscript, you need to be familiar with the types, but we don't have time to talk about it in this lecture. But the fragment is something that you will see in the output expression. Okay, the basic, of course, is a key signature. Then we have similar to the policy. It's almost the same. And when you have the condition, it looks a bit different. Okay, we can see that we have end underscore v, which mean that you must verify the expression, and then we have few versions of or. Okay, we can satisfy x or z, but then we have a version that says most likely we will use x, so it will build that in a different way. And again, we have the threshold. This is a partial list. In the official site, there's a full list. Now, as I said before, the implementation of policy to Miniscript is implementation dependent. Okay, but the mapping of the Miniscript to script is one-to-one, and you will always get the same result, okay? And this is also, the mapping is from the official site. And we have the basic key operations. Again, we can see that, for example, the PK key is just checking the signature of a key. And actually, you will see that in your script, in your result script. Etc. For all the other operations, it's just a one-to-one mapping of the Miniscript fragment. Beside the fragments, we have wrappers, and the wrappers just change the way the fragment is behaving. Okay, for example, if you have a V, this means that you must verify. You must use verify commands for this script. Sometimes you add swap, maybe you want to use alternative stack, etc., etc. It's just something that you add before the fragment. Let's see it in an example. Okay, if we have key in the policy, it will be translated to Miniscript, something like that. The C is for check. Okay, it's for check wrapper, and the pk underscore k is the command to check the signature of the of the key. The same for or, and we can see end that will be translated to end v, and the probabilities we talked before. It's the way to say, well, I'm usually using this key, so please create a script that will be efficient to use with this key. Okay. And this key is my backup key, so maybe I will use it in disaster case, but you can do it less effective in terms of fee, of course. And we can see that DK multisig is translating to something like that. Threshold will be also translated to threshold key, but we will add some wrappers to it. Okay, so It will be a bit more complex to understand, but then again, it's the wrappers that sometimes you can uplift the Miniscript expression back to the policy by just removing the wrappers. In this case, it will work, but it's not always. It's not guaranteed that it always will be like that. We will see that sometimes it chooses different fragments for multisig. So remember our family policy? We wanted to create something that the parent will be able to spend together or with a backup key, but after 1 year, the kids will be able to spend it, 3 kids together or 2 kids with the lawyer office. So how we represent it with the policy? We will create an or expression because we want the parents to be able to sign, or this is the other expression of or, this is the other side of the or, that's saying after 1 year, we need the threshold, like we need the signature of this multisig. And this multisig is based on, we need 3 signatures from this key or that key. Okay, we have 4 keys represented here. And this threshold is composed inside as it represent the signature of the law office. It will be translated to a bit more complex Miniscript expression. As we can see, we have a multi here. Why the Miniscript chose multisig instead of threshold? Well, when we have a clear multisig without any time lock, it will be trash. And when we use something that it's, oh, sorry, I mixed the opposite. If you're using a simple multisig, it will just use the multi keyword. But if we're using something that involved with another policy, like for example time lock, it will use trash. So the script output is something like that. Okay, this is the family policy script. It's not so simple, and it's really hard to write this and make sure that it will be satisfied without malleability and stuff like that, and also to create the most efficient script available. Now the question arises, what are we doing with this script? Okay, we cannot just use it as it is. Maybe if you are writing a solution in your company that, okay, maybe you want to use script, you can do that. But usually you will want to take that and use it in a tool, okay? And for that we have the descriptors. Miniscript working great inside the descriptors. Now, most of the modern models nowadays use output descriptors, and the Miniscript use them as a wrapper. Okay, the descriptors handle key derivation, and it describe the path, and the Miniscript describe the spanning condition. Now that combination is help us to build and sign a really complex script. For example, here we have a descriptor that contain an output script that requires 2 signatures of 2 keys. Okay? Now let's understand a bit what is a descriptor. A descriptor syntax looks like this: the function, so the descriptor itself, the key, and a checksum. Okay? And if you look on the example here, we can see that we have the key origin, and we described how we derive this key from this public key. Okay? And then we have the checksum. Why do we need the checksum? Because sometimes people want to transfer it, sometimes maybe they want to copy it by hand. So the checksum helps to avoid errors in this area. Now, note only also this strange syntax that's saying we want this also to for the internal addresses, for the external addresses. Okay, external, sorry, and internal for change addresses also. So we can do that in one descriptor instead of two descriptors that will describe one for change and one for external addresses. Now, the common use descriptors types. We have few descriptors, and the ones that we want to work with for Miniscript are WSH with the script hash, and taproot. We also have a limited support in script hash, but it's better not to use it. It's for legacy, and Miniscript will work the best with SIGWIT and taproot. Now, Miniscript in Bitcoin Core, there's been a really good work, and I think it's supported the best in Bitcoin Core. If we want to import a descriptor, we just use this command, import descriptor, and from now on, we can use this descriptor to derive an address. For example, we can do it. This one is to import it to our wallet, and this one is just to derive from a specific descriptor, okay, to create an address for a specific descriptor. Now, there's a lot of APIs supported in Bitcoin Core. You can scan from scan output and descriptor info, and you can use it for a lot of APIs. Eva did a good work here, and I think that almost everything now supports descriptors. And by the way, you cannot create now a legacy wallet anymore. You can just create a new descriptor. There's a workaround, but Bitcoin Core now supports only descriptor wallets. Now, let's finish our example. How do we sign that complex script, right? This is a complex script. How can we sign that? Of course, by using PSBTs. We can create a PSBT for our wallet. Sorry, my glasses are slipping. So we can create a PSBT for our wallet, and mom will sign first. She will use wallet process PSBT call with the PSBT we just created and funded, and then dad will sign also after that, and it will be the same if we need more signatures. Okay, when you see an example of PSBT with two signatures, is like it's linear. So even if it's composed, it's still a linear process. So you can add a lot of signatures to the PSBT. Then you need to finalize it and just broadcast it to the network. Some tools and resources about Miniscript. So first of all, we have the official site of SIPA, of Peter. It has some examples here that you can play with, starting with the basic for a key and much more complex. And you can also analyze it, and you can see the script, you can see the weight of each script, and you can see the result here. Another really nice tool is Minsk by Nadav Ivgi. It's called Shesek. And you can write your own. It's a really strong tool that you can write your Miniscript expression inside a descriptor, and then you can see the Miniscript. This is the policy, yes, and you can see here the Miniscript expression and also the script, and final also the address, which is really nice. You need to remember that this script, after all, represents by an address. And we can see here our policy, the family policy that we wrote. We have the keys, and this is the policy. It will be translated to this Miniscript. And again, we can see the script here. and the others here. There's also a site called Output Descriptors that shows most of the wallets that support Descriptor, and I think that a lot of them already support Miniscript inside that. And one more nice thing, yesterday in the hackathon, I wrote a nice site, Miniscript compiler that I'm going to make it better. And then you can see also the errors in a better way. One of the things that it's hard to find the errors in those expressions. Now, I'm trying to achieve that and to make a better online compiler. And the wallet that currently supporting Miniscript, first of all, we must mention Liana, that I think they were the first, for sure they were the first to adopt that, and they really pushed others to work with it. Sparrow wallet, of course, Bitcoin Core and others are adding support. And to sum it up, it's, as we said before, BitcoinScript has challenges. It's complex, it's not composable, and you can do painful mistakes. And Miniscript helps you to solve that by 3-layer architecture, human-readable policies, and it's really much more easy to back up your wallets. Thank you.